Hello viewers, in today's session we are going to discuss an important problem related to Dirac delta function. And here we are going to find out the Laplace transform of the delta function, that is delta of 2t square minus t minus 3, right? So in this class we'll see how we can find out the Laplace transform of a delta function in which we have a quadratic polynomial, right? So let us start. So let us first take the definition of Laplace transform of a function. Suppose we have a function, say f of t, right? Then the Laplace transform of this function f of t is given by this integral, that is 0 to infinity. We have e raised to minus st, and here we have the function f of t dt, right? So this is the definition of Laplace transform of function f of t, right? Now here the Laplace transform of this delta function may be written as the integral 0 to infinity, and for the function f of t we have this entire term, right? So we have e raised to minus st, and we have here a delta of 2t square minus t minus 3 dt, right? So the Laplace transform of delta of this quadratic polynomial is given by this integral. And now we have to find out the value of this integral using the properties of Dirac delta function, right? So let us call this integral as I, which is also the Laplace transform of this delta function, right? So let us take this function as g of t, right? So now we can write 0 to infinity. We have e raised to minus st, and here we have delta of g of t, and where g of t is our quadratic uh, polynomial, that is 2t square minus t minus 3. So now whenever we have to evaluate the integrals involving the delta function, where we have a function inside the delta function or the delta symbol, then we use an important property of Dirac delta function, right? So the property goes like this, that is delta of g of t is given by summation, and here we have delta of t minus ti, and in the denominator we have the absolute value of g prime of ti, right? So we have already solved these type of problems in our earlier lectures. So here I will make use of this property, right? So delta of g of t is given by summation delta of t minus ti, where I denotes the roots of this function, that is g of t is equal to 0, right? So when we solve this equation g of t is equal to 0, then I represents the total number of roots of this equation g of t is equal to 0, right? So here we have a quadratic equation. It means this equation has only two roots. So let us denote the roots by t1 and t2, right? So here I goes from 1 to 2, right? So we can now write this expression as delta of t minus t1. First we'll take I is equal to 1, and here we have the absolute value of g prime of t1, and then here we have the summation sign, so we have delta of t minus t2 divided by the absolute value of g prime of t2, right? So let us first calculate the value of t1 and t2. from by solving this quadratic equation. So let us solve this equation by splitting the middle term. So we can simply write 2t square minus 3t plus 2t minus 3 is equal to 0, right? So the factors are minus 3t and 2t, right? So let us take these the groups of these two terms. So here we have t, and then we have 2t minus 3, and here we have 1, and 2t minus 3 is equal to 0. So we have t plus 1, 2t minus 3 is equal to 0. So t plus 1 is equal to 0 gives us t is equal to minus 1. And 2t minus 3 is equal to 0 gives us 3 by 2. Right? So we have two values of t. So let us call t1 as minus 1 and t2 as 3 by 2. So now the next step is to differentiate g of t, right? So the derivative of this function is g prime of t. So we have the derivative of 2t square minus t minus 3. So this is 4t minus 1, right? So the derivative of g of t is given by 4t minus 1, right? Okay, so now here we have to find out the value of mod of g prime of t1 and mod of g prime of t2, right? So let us separately find out this value and this value. So we have mod of g prime of t1 is given by mod of g prime of t1 is minus 1 here. So we have mod of g prime of minus 1 is given by taking t is equal to minus 1 in this expression. So we have 4 times minus 1 minus 1. So this is minus 4 minus 1. So this is mod of minus 5. That is simply 5, right? So the value of g prime of t1, mod of g prime of t1 is 5, right? Similarly, we can find out the value of mod of g prime of t2. So this is mod of g prime of t2 is 3 by 2. So here we have 4 times we can take t is equal to 3 by 2. So here we have 3 by 2 minus 1. So this is 2 times 2 is 4. This is 6 minus 1, that is mod of 5, that is equal to 5, right? So the value of mod of g prime of t2 is also 5, right? So now let us write the value of delta of g of t. So we have delta of t minus t1. T1 is minus 1, and here we have 5. Then we have delta of t minus 3 by 2, and here also we have 5, right? So now we have delta of t plus 1 over 5, and this is delta of t minus 3 by 2 over 5, right? So delta of g of t is now given by the sum of two delta functions. So let us substitute the value of delta of g of t in this integral, right? So we have now I is equal to the integral 0 to infinity. We have e raised to minus st, and here we can write delta of t plus 1 over 5, and then we have delta of t minus 3 by 2 over 5, right? So now we have to evaluate here these two integrals. So now let us write this integral as a sum of two integrals. So the first one is 0 to infinity e raised to minus st. Here we have delta of t plus 1 dt, and we can take this 5, that is 1 over 5 outside the integral, and then we have 1 over 5 and integral 0 to infinity e raised to minus st and delta of t minus 3 by 2 dt, right? So now we have to calculate the value of these two integrals, and in order to get the values of these two integrals, so we'll make use of the definition of delta function. So now let us define the Dirac delta function by this integral, that is from infinity, minus infinity to infinity. Here we have f of x and delta of x minus a dx, right? So we know that the value of this integral is given by the value of the function f of x at this point, right? Because the delta function is not 0 at x is equal to a, and the value of this integral is equal to the value of this function f of x at this point, that is x minus a is equal to 0, that is x is equal to a, right? So we have f of a. So we'll make use of this result to compute the values of these two integrals. So in the first case, we have the function f of x. So here we can assume this function as f of t because the variable is t, right? And here we have t plus 1. So here t plus 1 can be written as t minus minus 1, right? And we can easily see from this integral that this value, that is minus 1, that is t is equal to minus 1, is not covered, or it is not within this domain, that is 0 to infinity, right? So this point t is equal to minus 1, it lies outside this boundary, that is 0 to infinity. So the value of this integral is equal to 0, right? Because the value of this integral is equal to f of a only when this point x is equal to a, it lies within the limits, right? So here we are taking the limits minus infinity to infinity. So here we have minus infinity and here we have plus infinity, right? So this point must lie within the lower limit and the upper limit, and here t is equal to minus 1, it does not fall within these two bounds, that is 0 and infinity, right? Because here we have 0, here we have infinity, and t is equal to minus 1, it lies over here, right? Okay, so the value of this integral is equal to 0. So we are now left with only this integral. So here our function f of t is given by e raised to minus st, and here the value of a is given by 3 by 2, right? Here the value of a was minus 1. So here 3 by 2, it lies within 0 and infinity. So the value of this integral is now equal to 1 over 5. Here we have the factor 1 over 5, and the value of this integral is it can be obtained by replacing t by 3 by 2, right? So we have minus s times 3 by 2, right? So we have 1 over 5 e raised to minus 3s over 2. So now we can conclude that the value of this integral I, which is also the Laplace transform of this delta function, is equal to 0 plus 1 over 5 e raised to minus 3s over 2, because the value of this integral is 0, right? So we have 1 over 5 times 0 plus 1 over 5 e raised to minus 3s over 2. So this is simply 1 over 5 e raised to minus 3s over 2. So the Laplace transform of this delta function is given by 1 over 5 e raised to minus 3s over 2.